In other words, that only one person or one being has to break through the boundary for the entire state system to collapse and rearrange itself. It's December 21st, 2012, and through the worldwide VRML hookup of the internet, everybody with an IQ above 10 has gathered in the great collective space to witness the first attempt to send a human being through time. And at the World Temporal Studies Institute at La Chorrera in the Amazon, the president of so-and-so makes a speech. The lady time traveler makes a speech. She straps on her helmet. She steps into the machine. The fanfare for the common man is played. A button is pushed. And off she goes into the future. Now, what has always been put against time travel schemes is what's called the grandfather paradox. And this is easy to understand. It goes like this. If time travel were possible, I could travel back in time and kill my grandfather. If I did that, I wouldn't exist, so I couldn't do it. Therefore, there's a closed loop of paradox. Therefore, time travel is impossible. I put this to the mushroom, and it said, well, time travel is possible, but you can only travel backward in time as far as the moment of the invention of the first time machine. You can't travel further back in time than that because there were no time machines before that. So it's a kind of barrier. Well, so then I thought, so then here was my model of what would happen when the lady temponaut sails off into the future. Let's forget about her and ask the question, what happens next in our world? And my first guess was what happens next is thousands and thousands of time machines arrive from all points in the future. They have come back through time to witness the first time machine take off. It's as though you had a Piper Cub that you could fly to Kitty Hawk, North Carolina, to that windy morning in late December when the brothers Wright rolled it out of their bicycle shop and fired her up. And then I said, well, but wait a minute. We haven't dealt with the grandfather paradox. One of these time machines from the distant future, on its way to the first time flight, could stop off and kill the grandfather of the driver of that time machine, and we haven't gotten anywhere at all. So then I produced a slightly more complicated model, but it works, and so here's what it is. It's that because the future is not what we think it is, well, here's a metaphor which makes it more clear. In this world that we're living in right now, we have people such as Bill Gates and his research and development teams, and we have people such as the upriver people in London that I spent time with, bare-assed people living at a very minimal cultural level. Gates and his people and this Amazon tribe occupy the same planet and the same moment in history. But who is influencing who? Very few people in the world are taking up the Amazonian lifestyle or point of view. Millions and millions of people are going Gates' direction, and more will. So what I concluded from that is that advanced states of culture tend to squeeze out or mitigate less advanced states of culture. Now let's return to the time flight. What happens when the Lady Temponaut goes into the future is not that time machines arrive from all over the future. What happens is that the entire rest of the history of the universe happens instantly. In other words, a future, evolutionary developments, conquest of the galaxy, vast technologies that allow star flight and wormhole travel and all that, the fruits of all that are delivered instantly to our doorstep in 2012. I call it the God whistle model. In other words, we end the whole thing. We collapse the state vector, and everything goes into a state of novelty. And what happens then, I think, is the universe becomes entirely made of light. This is a sort of the cherry on the cake. You know that there is something in physics called the principle of parity. This is that particles can appear out of nothingness as long as they appear in pairs, such that after a certain period of time, the two pairs are not the two the members of the pair encounter and annihilate each other. And when this happens, physicists say parity is conserved. Now, it's known in quantum physics that there is a phenomenon called vacuum fluctuation. Vacuum fluctuation is a situation where in absolutely empty space, suddenly out of the quantum subspace, particles jump into existence. They follow trajectories, they encounter each other, they annihilate each other, parity is conserved, and so it's okay. It's okay. Well, so then you talk to these quantum physicists and you say, well, how large can one of these vacuum fluctuations be? And they say, well, they last milliseconds, nanoseconds. You say, well, is there a theoretical upper limit on the size of a vacuum fluctuation dictated by theory? And they say, no. It's simply that the longer the fluctuation lasts, the rarer it is. So in other words, the longer a fluctuation lasts, the less likely you are to encounter one. Well, then you say, well, is it possible that this entire universe is such a vacuum fluctuation? You say, well, yes, but that would be very rare to have such a long one. You say, well, hell, you only need one. Calculating the probability of a unicate event is a fool's game. I mean, it's either 100% sure or zero sure. So here is a model, and I took this from the Swedish physicist Hans Alfvén, who hasn't gotten enough credit, but who's really a very interesting thinker. Imagine that the universe is this kind of vacuum fluctuation, a 17 billion year long vacuum fluctuation. Well, what it means then is that at the Big Bang, not one universe was born, but two. And they sailed off into superspaces and have no connectivity with each other, or they have Bell non-local connectivity or something. But anyway, they are distinctly separate. But they are, unbeknown to each other, on a collision course with each other. Parity must be conserved eventually. And a model like this holds open the possibility of the instantaneous transformation of the entire cosmos, because the collision of these two universes would not occur in three-dimensional space. It would occur in a higher dimensional space. So this cosmological model holds out the possibility that all matter in the universe could be instantaneously canceled in this encounter with the antimatter twin that was born at the beginning of the cosmos. Okay, if you're still following, we're almost to pay dirt.